Hello everyone, in this problem we are given n dice, and unlike a normal dice which has faces labeled from 1 to 6, here each die has k faces labeled from 1 to k. We are also given a target, and for each of the n dice we have to throw them, and we have to find the number of possible ways in which the sum of the faces equals to target. Let's look at our first example. Here we have only one dice and we have to reach a target of 3. This dice only has values from 1 to 6. So there is only one possible way to reach the target of 3 by obtaining 3 in our dice throw. So the answer is only 1. Let's look at our second example. Here we have 2 dices, so we have to throw 2 times. The target required is 7 over here, and the dice has value from 1 to 6. These are all the possible values for the first and the second throw to result to a sum of 7. We see that there are 6 possible permutations which result in the sum of 7. So our answer is 6. Let's try to understand this problem with the help of this example. Here we have 4 different dice, so we have to make 4 throws, and each dice has only 3 faces, and we have to reach a sum of 10. Let's see what happens when we throw our first die. We can either have 1, 2 or 3 from the first throw. So let's write it down. We have already used one of our throws, so we only have 3 throws remaining now. Let's look at this example. If we have obtained sum of 1 from the first throw, then we only require a sum of 9 from the remaining 3 throws. Similarly, for the other 2 throws, we can see that if we obtained a sum of 2, then we only have 8 remaining and we have 3 throws left. If we look at this one, then the only way we can obtain 9 from 3 throws is by throwing 3 times consecutively. Similarly, for our next outcome 2, we can have either 1, 2 or 3 in our next throw. So when we look at this problem at this level now, we see that this boils down to a new problem. For example, if we were to look at this problem, we have to reach a sum of 7 from only 2 throws, and we see that this is not possible. When we look at this problem now, we see that we have to reach a sum of 6 from only 2 throws, and this is exactly same to this problem over here. So you can notice that there is some repetition of work that we can reuse every time. We see that this problem is already solved over here, so we'll use the same value. So this is a dynamic programming problem. Let's look at the decision tree to figure out the time complexity. We have 3 phases. For each level, we are going to have 3 different values over here. For example, 1, 2 and 3 for the first throw. And for each of these outcomes, we are again going to have 3 different values over here. Similarly, we are going to have 2 more levels, and then we can use this to find the answer by using a cache for each of the computed values. So in general, we are going to have n levels, and for each of those n levels, we are going to have k different outcomes. So the time complexity is going to be n into k. And the space complexity is also going to be n into k because we have to store the pre-computed values. This is going to be only in the case for memoization solution, where we are going to write the solution recursively. We can also optimize the space complexity to be only of O of k by using a bottom-up approach, which we have already covered so many times in this channel before. Let's implement a memoization solution because I feel that is going to be acceptable for any interview. Let's first write our recursive function. Here we are going to need 2 variables. One is the throws remaining. We'll initialize it with the number of throws we have, which is n. And we are going to also keep a variable to keep the count of the target that we have to achieve, which is the target remaining. It is initially going to be the target itself. Now let's write our base condition. So firstly, we'll check if we have no throws remaining. In that case, we'll check if the target remaining is 0. That means we have achieved our target. In that case, we are going to return that this is a valid count. So we are going to return 1. Else we can directly return 0 because it is not possible because we don't have any throws left. Now we are going to write our second base condition. if that our target remaining is less than or equal to 0 and we still have any throws left, that means we can never achieve it because we cannot have a negative throw. So let's initialize our result to be 0. And now for each of the valid k faces, we are going to consider each of them as a valid throw. So we'll have a for loop from 1 till k. And for each of these throws, we are again going to call our recursive function. So, but in this case, we'll have one less throw. So our throws remaining will be -1. And we are going to subtract this throw value from our target remaining. And at the end, we can return our answer once we have considered all the different throws. We are not done with our recursive function. Let's make sure that we don't forget to cache it. Now we can call our DFS function. We have already provided the initial value, so we don't have to provide it anymore. And at the last, we have to mod our result with this constant value. This is a requirement of the question itself. If this video was helpful, please leave a like and subscribe to the channel for more such content. If you have any doubts, concerns, or any feedback regarding this solution, please mention in the comments. Thank you for watching and see you soon.